Hi everyone, welcome back to my channel. In today's video, I'll show you how I implement layer 3 switching using a TP-Link switch. So instead of relying on your router or gateway for Inter VLAN routing, we'll make the switch handle that process. Traditionally, switching happens at layer 2, while routing happens at layer 3, but with this design, you'll see how much more efficient your network can be. When a layer 3 switch takes care of Inter VLAN traffic. In most TP-Link Omada tutorials you'll find, Inter VLAN routing is usually handled by the gateway devices like the ER605 or ER7206. That's often implemented using a router-on-a-stick design, where multiple VLANs are defined on the gateway interface and uplinked to the access switch. Router-on-a-stick works fine, but as your internet speeds get faster and LANs get more complex, it puts a heavy load on that single uplink between the switch and the gateway. An alternative is to make your gateway act as the core distribution switch, or get a more powerful router with stronger uplinks. But unless you have a gateway with a very strong backplane speed, LAN-to-LAN traffic can be slowed down because all Inter VLAN traffic still passes through the gateway. With layer 3 switching, things change. Internet traffic is still handled by the gateway. Inter VLAN traffic is handled by the switch. This significantly improves local performance. Pros: switches usually have more ports than gateways, so you'll have plenty of routable LAN ports. Newer TP-Link switches offer multiple 10G ports, more than what most gateways provide. Inter VLAN traffic performance is boosted thanks to switch backplane speed. Cons: layer 3 switches don't support NAT, so they can't replace your gateway for internet access. They also don't handle WAN features like VPN, firewall, or port forwarding. Your gateway still takes care of that. Setup is more complex and requires deeper networking knowledge. If you're new to networking or Omada, it might feel intimidating, but if you enjoy learning and want better LAN performance, this is a great project to try out. Here's the hardware I'll be using in this demo: gateway, ER605 Vita Layer 2 Plus switch, SG3210 access point, Ubiquiti Loco M2. These are older devices, but the process is the same for newer hardware. On my ER605 gateway, you'll notice that I only have one VLAN interface defined. At first glance, it looks like a flat network, but it's not. All VLANs beyond VLAN1 are handled at the switch level. On the switch, I've already created multiple VLAN interfaces, VLANs 30, 40, 50. Each VLAN has a switch virtual interface defined with a static IP 192.168.30.1 subnet mask DHCP server-enabled DNS and default gateway. This makes the switch responsible for Inter VLAN routing. Since the VLANs are only defined on the switch, the gateway doesn't know about them. To fix this, we use static routes. On the ER605, go to transmission routing static route. Add the subnet of each VLAN endpoint into the switch's management IP, in my case, 192.168.0.2. This way, the gateway knows how to reach all VLANs behind the switch. I tested this by moving my PC across VLANs. On VLAN1 management, I had internet access. When I moved to VLAN 30, my PC received an IP from the switched HCP and could reach other VLANs, showing that the layer 3 switch was successfully routing between VLANs. Internet only works once the gateway has a static route to each VLAN. Let's now create a new VLAN from scratch. VLAN 60. And that's it. You've just seen how to set up layer 3 switching on TP-Link Omada, a much more efficient way to handle Inter VLAN routing. If you found this guide helpful, please consider watching my videos in full, liking, and subscribing. It really helps my channel since this is a niche topic.